Alright, so this is coordinate geometry, named that quadrilateral. Like I said, in each unit we're going to end up doing some kind of graphing. We already did Pythagorean, we're going to end up doing some kind of graphing. All we're trying to do is classify a quadrilateral as a parallelogram, rectangle, rhombus, or a square based on its properties. So there's many ways to do this, but through doing this for a while now, we figured out the best way to teach y'all and the most minimal amount of steps is to do it this way. We're going to teach y'all 2 steps to do to check and see if a quadrilateral is either a parallelogram, a rectangle, a rhombus, or a square. The 2 steps are: step 1, check congruency of diagonals. Make sure I spell that right. I'm writing fast. Check the congruency of diagonals. So we're going to check and see if the 2 diagonals are congruent inside of our quadrilateral. Then after that, we're going to check the slopes of the diagonals. After we check to see if we're congruent, we're going to check the slopes. If our slopes are perpendicular, that's going to tell us a lot. If they're not, that's going to tell us a lot too. Alright, so I'm going to go through the 4 cases that you may have when you're doing this. Case 1, if you have a parallelogram. If you have a parallelogram, your diagonals are not congruent, but they bisect each other. That's the case for all of these parallelograms. The diagonals won't be congruent though, if it's a parallelogram. If it's a rectangle, the diagonals are congruent and they bisect each other. If it's a rhombus, the diagonals are not congruent and they are perpendicular, meaning they create right angles in here. So if it's going to be a rhombus, the diagonals won't be congruent to each other, but the diagonals will be perpendicular. So they'll have perpendicular slopes, which I'm going to remind you of down here at the bottom too. If it's a square, the diagonals will be congruent to each other and it'll be perpendicular. So you have right angles on this one too. Alright, honestly, when you're doing these, it'll be easy to spot certain shapes. You just have to make sure you check to be sure. The 2 that kids get mixed up the most when they're doing these are the parallelogram and the rhombus. Because when you draw them on a graph, they actually look closer to each other in shape than you think they would. So you definitely have to check and see that. Don't just assume. And some of y'all gonna try to assume you're gonna get wrong. And actually, we assumed on a rectangle one on our home learning earlier, and it really wasn't a rectangle. You'll figure that out when you get there. Alright, I'm gonna show you how to do the work properly. But some of y'all, like I say, just like when we did classifying triangles in the last one, I showed you how to do the work. But some of y'all just drew the triangle on the graph and tried to guess anyway without showing any work. Some of y'all still gonna do that, and you're giving yourself a 50-50 chance of getting it wrong. Maybe even more than that. Maybe a 25% chance. Practice number 1: given the vertices, determine the quadrilaterals most. Oh, I skipped something. Sorry. I need to remind y'all of something before we do this, because I know some of y'all don't remember. Y'all need to remember what a perpendicular slope looks like. Up here, I'm just doing a couple examples up here for us. Perpendicular. Remember, 2 slopes look perpendicular. This should be what we call opposite reciprocals. Tim, you're a good person to start with. Say I tell you the slope of a line is 2/3, Tim. If I tell you the slope of a line is 2/3, what would the perpendicular slope to that line have to be? -3/2. Thank you, Tim. Kids last class was 3/2. They were saying all kind of stuff out their mouth. I don't know. We'll do one more example. Over here is Isaiah. Isaiah, say I tell you the slope of a line is -3. What would the perpendicular slope for that line have to be? Say it again. Nope. Nope. It's 2 tries now. I'm sorry, sir? 1 and 3. What does that mean? Can you just say it correctly, sir? There you go. 1/3 or 1/3. I got you now. I understand that. That's English. Huh? No, it wouldn't be negative. Opposite reciprocal. Opposite flip the sign. Alright, so I just need y'all to recognize what perpendicular slopes look like. Again, we already did all that, so it's just a refresher. Down here, we're graphing this image, A, B, C, D. 9, -4, 8, -2, 2, -5, and then 3, -7. I know what this looks like to you, and you're going to try to guess without doing any work. I wouldn't suggest that, especially on the home learning, because I realized the one on there, you shouldn't guess. You should do the work on that one. Because I guessed and I guessed wrong. We had to correct it earlier. I know it most looks like a rectangle, but it could be just a parallelogram. For a rectangle, you have to have all right angles in here. These angles might not be right angles. They might be off a little bit. To do the check, all you want to do is check your diagonals for congruency and then slope. So I'm going to put diagonals in. You have to put your own diagonals in, obviously. From A to C and B to D. Missing microphone. I'm looking for Alright. First thing I'm going to check is if my diagonals are congruent. To check that, they are diagonals, so I need to draw triangles around them and do Pythagorean. First one, AC. I'm going to go up from here, and then I'm going to go to the right till I get over to A. It's going to be a small triangle, but you can see it. My vertical count is going to be 1. Horizontal count is going to be 1, 2, 3, 4, 5, 6, 7. So I get 1 and 7 for AC, that diagonal. The other diagonal is going to be BD. I'm going to get a count for that. I'm going to do a triangle. I'm going to go from D up to B here. My other diagonal BD. I'm making a triangle around that. This ain't nothing that we haven't done before, so mine shouldn't be blown right now. My vertical for this one is going to be 5. My horizontal for this one is going to be 5. So I got my 2 sets of numbers. My numbers are different, but I told y'all different numbers doesn't mean stuff still can't come out the same when you do Pythagorean. You should try this. Out to the side here, AC is my first diagonal. I'm going to do 1 squared plus 7 squared equals C squared. 1 squared is 1. 7 squared is 49 equals C squared. Add those together, 50 equals C squared. Square root, square root. Square root of 50 is going to be a decimal. We're just going to leave it like this, square root of 50. Next to that, I'm going to do BD. BD is my other diagonal. I have 5 and 5 for that one. Equals C squared. 25 plus 25 equals C squared. Add those together. 50 equals C squared, square root. C equals square root of 50. So obviously, even though I had two different sets of numbers here, I still got the same length for both of my diagonals. The fact that both of those are the same length, I automatically can exclude a parallelogram and a rhombus. Because if my diagonals are the same length, it has to be either a rectangle or a square. And once you get to this point, it's obvious it ain't a square. So you can see it's a rectangle. But to do the final check, it would just be to check the slopes. And it ain't even much work you got to do to check the slopes. Honestly, by drawing the triangles that we drew, we already found slope. For example, AC. Remember, slope is rise over run. From A to C, went up 1 over 7. The slope of diagonal AC right here is 1/7. And then the slope for this diagonal BD, rise was 5, run was 5. Slope on this one is 5 over 5, which reduces down to 1. And so you would just be looking at the two slopes. This slope and this slope are not perpendicular of each other, so my diagonals are congruent, but they're not perpendicular. That qualifies this to be a rectangle. This is how you would check instead of just assuming. It's not much work to do. Some of y'all gonna be lazy and not do that. That's fine. You're probably gonna get the one on the test wrong and the one on your homework wrong. Got 2 more to show you. Actually 3 more. I'm gonna do one of y'all practice ones with y'all. Let me zoom out a little bit. On the back, number 2. Determine the most precise quadrilateral by placing a check in the box with the coordinate points Q, R, S, T. Out to the side, they give you your 4 choices. You should already know them anyway. We're graphing Q, R, S, T. Q, -2, 7. R, 1, -5. S, 4, -7. T, 1, -9. Q, R, S, and T. This is my figure. Looking at it, look like it could be a rhombus. We need to check to be sure. Checks are not hard on this. Put my diagonals in. Diagonal for RT and diagonal for QS. Remember, we want to know the length of the diagonals, see if they can congruent or not, and then we want to know if they're perpendicular. This shouldn't take y'all long because you should realize the RT and QS are on here vertically and horizontally. So you should understand that you could just count that. There's no real work you have to do. Abigail, what's the length of RT? 4. What's the length of QS? Are your diagonals congruent? And you said no, so that makes this not a square, not a rectangle. It's got to be a parallelogram or a rhombus. To figure out which one on that, remember the rhombus is the one with perpendicular diagonals. Abigail, is RT perpendicular to QS? I would hope that you would say yes, they on there vertically and horizontally. Yeah, so you know it's a right angle right here. So that being said, yeah, I'm going to call this a rhombus. That's a very quick one to do, especially if it's that easy. No math was involved. Alright, the last type I got to show you, and we will definitely ask you this at least once. I think we asked you this twice on your test. It's an easy problem to get right. It's easy to get wrong too. I don't know. I teach y'all a good way, and kids be going off and doing their own thing and trying to figure out why they can't get it right. Number 3. It says with the points J, K, and L, find M if the points given form parallelogram J, K, L, M. So what's happening here? We give you 3 out of the 4 points on a parallelogram or any quadrilateral. It don't have to be just a regular parallelogram. We give you 3 out of the 4 points, and we want you to find the 4th point. First thing you should do is graph those 3 points that they give you. And 5, -1, 8, 2, and then 11, 10. What I usually do, I graph those, then I'm going to label them J, K, and my L. Now, being that I don't have the 4th point, I cannot draw the whole quadrilateral right now. But I can connect the points that they told me about. Go J to K and K to L. Go in the order that they named them. J to K, K to L. The reason I like to connect that part, and some kids don't do that beforehand, the reason I like to connect so I can show myself, okay, I know this is going to be a quadrilateral. I know they said it's going to be a parallelogram. For me, for this to be a parallelogram, I can kind of I'm showing myself where my 4th point has to be. Looking at this, my 4th point has to be in here somewhere, right in here. The reason I say that, you're going to see kids do this tomorrow on the activity that we do. They're not going to connect their points, and they're going to try to get their 4th point. Their 4th point going to be way down here somewhere. It's going to be something silly. I've seen a lot of silly stuff on the stuff that we do tomorrow. But your 4th point logically is going to be right here, up in here somewhere. To get it, you need to understand what shapes you're dealing with. A rectangle, a square, a rhombus, and a parallelogram itself, they are all parallelograms, meaning all opposite sides are parallel. That being said, if opposite sides are parallel, those opposite sides have the same slope. So if I get slope of one of the sides, I can just duplicate that. If I could duplicate a slope, I could create another slope up further on the figure, and I can figure out where my other point is going to be. Now, you got 2 different sides you can work with. You got JK and KL. I always use my shorter side. I'm going to use JK, and I'm going to duplicate that and figure out where my other point M is. So, J to K, I'm going to just get a slope from that. From J to K, you have to go up 1, 2, 3. Then you have to go to the right 1, 2, 3. This will be the slope from J to K, 3 and 3. To figure out my other point, I'm literally going to carry that slope up my figure and duplicate it. Only thing is, you got to make sure you do this the correct way. When you go up here, you do not want to start at point L and then count up and over from there. You're going to be off the graph. Point L is kind of on this same side with K. J is going to be on the same side with M when I create my new slope up here. So when I get up here, I kind of got to do my slope backwards. Even though I done went up 3 and over 3 this way, when I get up to the L, I need to go back to the left 3 and then down 3 to recreate this. So I'm kind of going in reverse when I get up here. So I get up here from L, I'm going back 1, 2, 3. And I'm going down 1, 2, 3 to create that same slope. 3/3. Once I do it, that should land me on my point. My point is going to be right here. Point M. And then, yeah, that is what Silver said. I don't know, you sit back there anyway, you can't see the TV. After that, you can connect your stuff. Yeah, the writer should look like a parallelogram after you finish. And then after that, you just need to give me what coordinate, the coordinate of M. Remember, what's M? Say it louder. 8, 7. Thank you. Yeah. So that is the notes, kids. This is the main one I need y'all. I think the other ones are easy. This is the main one I need y'all to pick up on. This is the main one kids struggle on. Alright, so I'm on the practice page now. I'm gonna do number 1 with y'all. Same stuff over here. Determine the quadrilateral's most specific classification. Parallelogram, rectangle, rhombus, square. Use the given information to do so. They give us our coordinates up here. S, T, U, V. Need to graph that. S is going to be at -9 up 14. I know these numbers are kind of shaky, but I ain't got good eyesight and I can see it. And then 110. Three, 0. And then -13 up 4. This is going to be S, T, U, and V. You only got one sheet of paper when you came in? I guess so. Alright, so that's my figure. Once again, looks obvious. You need to do some checks though, just be sure. I'm going to draw my diagonals in, S to U and V to T. Remember, we are checking congruency of the diagonals, and then we're checking the slopes of the diagonals. We're kind of doing both at the same time when we do the triangles. We just gotta use the numbers. So SU, this first diagonal, I'll tell you what I do notice about this one. This does happen to you sometimes. Y'all should notice that the diagonal SU is going down from left to right. So y'all should know this is going to have a negative slope. So when I draw my triangle, just thinking about the fact that I'm going to need to find slope later, I start by going down when I draw my triangle. Go down until I get to U, and I'm going to go over. Just so I can represent it correctly when I make my numbers. So SU, I know it's going to have a negative slope. It's down, it went from 14 all the way to 0. So that's negative 14. And then it went from -9 to -3. That is 6. My other diagonal, VT. or TV, whichever way you look at it. It's going up from left to right. It's a positive one. So I gotta rise however far. I think I went far enough. There, right over. Go up 6, and then to the right. And from negative 13 to positive 1, that's positive 14. So this is the reason I like doing both of my triangles first, so I can look to make sure and save myself time and energy. On this one, Robert, if you look at both of my triangles that I made, I got 6 and 14, and then negative 14 and 6. But you should know when we do Pythagorean on both of those, we're going to get the same answer, right?
Yes, sir.
So there's no point in doing it if all I would need to know anyway is if my diagonals are going to be congruent. Obviously, when we do those triangles, it's obvious these diagonals are congruent, right?
Yes, sir.
Alright, so don't waste your time doing Pythagorean on this one. Just understand that, okay, I just proved to myself the diagonals are congruent, so I can move on and just check slope. The other thing, for if this is, I'm assuming y'all think this is a square. For if this is going to be a square, diagonals have to be congruent and the slopes have to be perpendicular. To check slope, this should be easy. SU is my first one. Slope on that one was down 14, so negative 14 to the right 6. Oh, didn't know I wasn't showing you that. Sorry. Let me zoom out. And then on my other one, TV. What you say?
Up 6, right.
Yeah, up 6, right 14. So obviously, even without reducing, y'all can see these are opposite reciprocal slopes. If you wanted to reduce them, you could. I mean, you don't have to. Reducing this, divide by 2 on top and bottom, negative 7 over 3. And this other one would be 3 over 7. These are opposite reciprocal slopes. So they are perpendicular. It's perpendicular and the diagonals are congruent. This is a square. This is the check that you should do. Should is the key word. So a couple things. Like I was showing y'all before, this one we didn't have to do Pythagorean on because once we got our two triangles, we obviously knew that they were going to be congruent. One like we did on our notes though, like when we did our triangles, we had 1 and 7 and 5 and 5 for our numbers. So you have to check, and you see once we did the check, they actually did come out to be congruent as well, even though we started out with different numbers. So don't assume because your numbers are different that they can't be congruent. They can be. I think that's a key thing that I'm saying. Marie, you picking up on that? Because you need to hear that. Don't assume because your numbers are different when you do your triangles that your answers can't be the same. I'm proving that to you right here, that it can be. I think some of y'all think that way. Y'all will draw your triangles and like, oh, my numbers are different, so they ain't going to be the same. This is proof right here that it can be. Other thing, too, I told y'all the main one that's going to get y'all is the rhombus and the parallelogram. I'm telling you, when you draw them on a graph, they look similar. Like, for example, I drew 2 on here, just messing around. One of these is a rhombus, one is a parallelogram, but honestly, both of them look like rhombuses. They are both not rhombuses. If you actually do the measure for both of these, one of them wouldn't come out right. So don't assume anything. You need to do your check. You need to check for the diagonal lengths, and then you need to check for the slopes. 10-4. Only other thing I need to say about the practice and the home learning, down here at the bottom, these questions can be answered by looking at your notes from properties of quadrilaterals that I gave you last week. With all the properties on there, just go on there. One thing will be true or whatever they're asking you about. On the back, there is a problem you need to scratch through. On the back, number 5, it asks you about properties of a trapezoid. We didn't talk about trapezoids. You don't have to answer that one. It won't be on your performance matters anyway. It's going to skip right over that one. Alright. Handle your business. I ain't leave you with too much to do.